Okay, this one's a good one for justifying why you should peer review each other's RIs, because you'll get a good idea of a lot of these things like tensile strength, elongation. This is really an RI thing that most students have done something similar, or that definitely people in the class will always do bits and pieces of it. Um, Once again, if you're going to get it right, don't stick with one. This is interesting as it says using data and I haven't used data. So I wouldn't accept any of these. I would pick on two of them, and two of them with data and that are clear, so maybe elongation. So disadvantage, it's stronger, so that's advantage. This one here, um, if it stretches, doesn't stretch very much, so it might be more brittle, so that's a disadvantage. And degradation rate is advantage. So I would put those things in there as well, but you're also not using data as well. So they said they used data and they didn't. So here you would say PLA has a percent elongation, less percent elongation than LPD, therefore PLA would stretch less. Um, you really want to put the data in there. So the PLA is only 6% uh, compared to LDPE, which is 148%. That's using the data, so I don't see data in their answer. That looks like they would have let them get away with it and say anything, really, without the numbers. Now, here once again, we're trying to go for two similarities, two differences, and two significances, and they've only really gone for one. Also, they've gone for intra-chain, so that I prefer that word chain to be honest, but it is actually intramolecular and intermolecular um, is the proper word. And also, um, the reasoning for that I've got on my notes, but because the beta sheets um, are quite long, so they can actually be of the same molecule. But because the bonding is so far away from, this could go on forever over here, um, and then come back because it's so far away. They've gone for this terminology, inter molecular, even though it really is all of them are intramolecular. Okay, so this similarity here, it's between two peptide bonds. They're on polypeptide chains. It's with amino acids. It kind of says two already. This one here is actually missing a key feature that's not 100% consistent, but a rule of thumb in that the alpha helix has less density of hydrogen bonding, and beta sheets have a higher hydrogen bonding, and so the significance is the alpha is more elastic and the beta plate is more rigid. Um, I would want you to say that anyway, but it just so happens to turn these into two as well. So better answer again. So always try and give a better answer than the mark scheme, and always try and give whenever it says 1 mark, give two. So you're looking for 6 points here. Okay, for this next question, I've just gone ahead and copied and pasted the data from the data booklet into there, and then I'll just analyze it before I've read the question because I can just see the question here. I need to do I need to know what's going on, basically. So we need to work out what's going on. Okay, so just looking at this here, this is the most positive, and this is less positive. So this one's going to be the copper going to Cu2 plus 2 electrons. Um, but the problem is there is no copper to come off, and so that will be no reaction. So that one won't work. This one here, the most positive is the copper, and so the magnesium will go to the reverse of what that is. That'll be plus 2.36, and so that will work, and that will be all good. So the total of that will be those two added together, so that will be 2.7 volts. That's all good. The copper will form one here, the magnesium will come off. So we're all good with that one. This one here, that's silver's the most positive here. And so silver will form one here, and then this will be reversed and be negative, so the copper will come off. And so we add those two together and we'll get 1.14 electrons going this way. Okay, so now we can see what the questions are. Predict the highest voltage and give you reasoning. So we know it's the second, so we're going to probably have to rewrite these equations. Um, and honestly, you have to really write all three because you have to justify why the other two are not greater. So all that's said here is sperm one's not simultaneous. There's no explanation. Cell 2 is not supposed to and will produce this. Um, cell 3 is spontaneous and will produce 0.46. I must have screwed that up. Yes, I did. So that's 0.8 minus 34. So got one wrong there. That's 0.46. Should teach me a lesson for being lazy with the writing on that. And so you need to somehow fit that all in here because that is a prediction, but it doesn't explain anything. So determines. The question isn't determine. The question is explain. Um, predict which is the maximum voltage. Yeah, I've got an issue with these because you really should rewrite this all out to show the numbers, how it's calculated. So they probably shouldn't do this many. They should probably just do two or three or make it worth a lot more. Um, hopefully they'll put in brackets. You can annotate the diagrams above or something. I don't know. All right. So second one here is determine the maximum voltage that produced by the fourth galvanic cell using bits of the first and second. Okay. So obviously you just grabbed the most positive and the most negative ones. So you've got minus 2.36 looks to be the most negative. The most positive looks to be silver is 0.8. So just adding those two together, as we can see here. So that one's got the equations written out nicely. Thank you, and the volt and that there. Um, and it said I had to do them. Thank God. All right. So determines cell 4 constructed using magnesium. Uh, that's sort of like a silly mark because you can see it there anyway. It's one of those giveaway marks. Identifies oxidation, so make sure. Um, so they didn't actually, well, they said anode and cathode. They didn't technically say oxidation and reduction. So it's always good to say oxidation or reduction um, as well. And then determines the voltage. So I'm sort of okay with that. Um, sort of part three really needs the equations done out. So it probably should be worth a lot more than 3 marks. And it's where all the work is done anyway. 3B is really quite easy once you've done all the work up here to understand what's going on in order to be able to do these questions. Okay, for question 4, I've just grabbed the readings for alkyaldehydes and carboxylic acids here so that I don't have to jump back and forth between the book. Now, it can't be a carboxylic acid because there's two oxygens there and there's no oxygens. There's only one oxygen here. And so it's just the classic aldehyde versus alcohol. Um, so the carboxylic acids normally give this broad band because there's an overlap um, with the CH bond here. If I could just get that in there. But there's this clear separation here, which is alcohol. So it's clearly an alcohol. Um, not much else to be said besides that. So that's fairly straightforward. Compensates alcohol, yeah, by this peak. Alcohol by that peak, fine. There's no peak there for carboxylic acid. Um, yeah, that's a little bit annoying. And also, yeah, and it's also said that there, that's not inferred to from a mark there. Um, yeah, I'm okay with combination. So get all these points as well as this extra point in there as your explanation. So just be very thorough. It does say 4 marks, which seems excessive. So yeah, you can get a couple more than four points, more than 4 points in there. So what are we dealing with here? C4H10. Um, so just check this is correct. C4H10. Um, 2, 4, that adds up. Butane 1-ol is what I always uh, prefer my students to write. You can just write butanol, but butane 1-ol is clear, especially when it gets more complicated, which it never seems to do in these exams. Um, and that's the other item, which is fine. This one sent me into a panic because it's my weakness, and the whole thing about memorizing is just low level learning. We should be doing more the higher questions in Bloom's. I don't see the point of memorizing stuff. I did guess it that structural must be different functional groups, and geometric is just rotations in space, etc. Um, like the cis trans. The reason it sent me into a panic is because if I jump to the isomers notes, you'll see the isomers notes here. I have highlighted in red the ones you do need to know, geometrical and structural, but they could have said constitutional. They could have said diastereomers, um, and then chain positional and functional isomers are all types of structural isomers. And I had to stop there because it just goes on and on and on. So when you start talking about isomer classification and start asking for definitions of the different types of isomers, you can see it's almost a dozen commonly used ones. So that's a little scary. But they're going to start asking for definitions of uh, a lot of these names are semi-obscure. Okay. So yeah, I don't. That's not really an intelligent question. I think they should ask some more difficult isomer questions where they have to think and show a bit more chemistry rather than memorizing. Okay, question 5. Um, Determine the strengths of 1 and 2 by comparing the Ka values. I kind of like this question, but um, they're missing a key assumption. So don't skip out on the rice here. They have sort of missed the rice. So do the rice diagram here, and then don't forget the assumption that this is minus x, and x is negligible because the Ka is so small, wherever that is of acid 1. Um, and how are you going to assume the Ka is so small? Well, because the amount of hydrogen ion that comes off is insignificant. So that's a double assumption, I guess. Um, so that should work out. Acid 2 has a larger Ka than 1. Which is all good. Okay, so I'm happy with that mark. Moving on, the balanced equation. Um, you don't have to add the water in there. You can just add the H plus if you like. Always need the equilibrium arrow. Sometimes I ask balance states. Sometimes I don't. So always put the states in there. Always make sure it's balanced, of course. Amphiprotic is pretty straightforward. If it gives off the H plus, there's no place for it to gain a H plus. So that's all very straightforward. This one here um, is fine. I guess there's error carried forward. But again, they've missed the rice. So don't skip the rice diagram in order to justify what these things are, the algebra for it. I just think it's the last one that's an issue. Um, this one again, they're just sort of like going for just general rules of behaviors of pH, and they're just this test really lacks stoichiometry, proper chemistry. I would give this to my year nines, 9 advanced that is, because all they have to know is that pH is a factor of 10, therefore divided by a factor of 10 or diluted by a factor of 10 or whatever. They really should make it far more difficult and say pH of 2.5 and screw people up because that's logarithmic and you'd have to do something far more complicated and get them to actually use the proper equations to work it out. So they've really missed out on a proper opportunity here, and I'll delete this question or make it not delete it because there's no stoichiometry in this exam except for at the very end. It's this really easy stoic that nines and tens do. So yeah, get rid of that and make it decent. Um, so they have to use proper stoichiometry calculations and rice diagrams, just to manage to avoid doing anything of any difficulty, really. Um, so question six, this is just a straightforward memorization question. So triglycerides, esters, right there. Saturation versus unsaturation. Um, they really should ask for a little bit more detail, like what's the significance of that as far as, access to enzymes or health or something. I don't know. Um, this one here, again, just memorization. Hydrophobic, hydrophilic end. Um, I don't like the word bridge. Maybe the non-polar has a high attraction to like dissolves with London dispersion forces. Would be a much better way than just saying bridge. 4 marks is also a bit excessive. Nonetheless, when they say four, you're going to have to go for eight. So there's one thing you can say. I would also draw the structure out and point to the different parts of it as well. That might get you to 6 or 7 points. But anyway, it's just a memorization question. Question seven again. How many times have they done equilibrium now? Paper one, two, and paper multiple choice, paper one and paper two. Way overused equilibrium. This one's just a straight memorization one again. They're just wasting space now. They've just lost 4 marks where they could ask them something um, that's not equilibrium and that's got some stoic in it, please. All right, so yeah, I think that's all pretty straightforward. All right, I just can't believe I'm looking at another equilibrium question again. Um, I know QCA watches these videos, so can they please do a content validity table on these things and a cognitive construct? I think it's cognitive validity on this because they've just got way too many equilibrium questions. Um, and the level of difficulty is not there either. And I think a table of all the questions plus the difficulty level would sort of pinpoint that out. But anyway, so here we are, another equilibrium question. Do the full rices on these ones. So that one's gone down zero point 0.1, so that'll be the 0.1 going in there. So it's gone down from 0.8 to double that because of the stoichiometry. But you can't really see that unless you do the rice nicely. Um, then calculate the equilibrium for this one. So that's just substituting the values in. So that should be pretty straightforward as well. Why are we doing this again and again and again? As you probably noticed by now, I'm not going to be happy with their explanations. So determines that 2 was higher than 1. KC was larger for 2 uh, to compensate for the increase in temperature. Um, so where was the temperature difference? 1 or 2? Um, temperature was higher for 2. So in 2, the Kc was at 0.25 here. And in 1, where's the Kc? 2.78. So 2.78, 0.02 gone to this, so it's increased. So the Kc is definitely increased, um, indicating the shift towards the products into them to compensate the increase in temperature. Compensate the increase in temperature. So this experiment is plus, so there's heat on this side, so it's endothermic. So what I like to do for these things, so it's going in this direction here, um, because you're going from kinetic energy to chemical energy. an increase, it makes it easier to go in this direction because you're increasing the amount of kinetic energy in the system. Whereas going from chemical energy to kinetic energy, you're not looking for any more heat, you're just releasing its heat. So it favors um, the reactants going into products. So the KC is products over reactants. And so if that one increases and that one decreases, therefore KC increases. You can also explain this with the Shatlers. I do prefer this one as a proper explanation, putting that in words. Um, this one doesn't really explain anything. Um, so that would be much better. Um, rather than just saying, um, yeah, maybe make that worth more. Okay. Okay, to finish off, this is the only stoichiometry there is, and it's just a simple mass stoichiometry. We teach yield and mass in year 9 advanced and in year 10 core, and this is year 11. Um, so none of it's in year 12. Um, so really not that that's a bad thing. It's just that it's very simple. And of course, I'm not going to be happy with this. So, um, number of moles, what is that? So you need the labeled formula. So mass on molar mass. Um, give me the labeled formulas here as well. Thanks. Um, and so just make your working a little bit better. That's it.